Hello, you guys. Today we are going to be looking at finding probability using a tree diagram. Far too often, math is all about equations and all about things that are sort of more abstract, especially at this level. However, the Texas Education Agency has done their part to make sure that students are well aware of visuals as well, and it appeals to those students who appeal a little bit more to a visual representation of different parts of the content. In this case, we're going to be looking at a visual representation of probability. As you see here, this is a probability for a compound event, a theoretical probability of a compound event. In this case, we're going to be looking at this particular example, then I'm going to show you another example that we're going to do from scratch. A deli prepares sandwiches with one type of bread, that's either white or wheat, one type of meat, ham, turkey, or chicken, and one type of cheese, that would be cheddar or Swiss. Each combination is going to be equally likely. We're going to find the probability of choosing a sandwich at random, getting turkey and Swiss on wheat bread. So if you notice, we have two different kinds of bread here. The reason that it's called a tree diagram is because, again, we're going to branch off from the initial choice. In this case, we're going to branch off with the three kinds of meat from each of these kinds of bread. So, again, you would have the option of getting a white bread sandwich that would have meat that is ham, turkey, or chicken. You then would have a choice of cheddar or Swiss for each one of those. So, this particular question is asking, again, the probability of getting a wheat sandwich with turkey and Swiss. So what would be the probability? In this case, I'm not going to consider anything having to do with the white bread simply because, again, it's not asking me for a probability of getting a white bread sandwich. It's only talking about wheat, and more specifically of turkey. So in this particular case, our sample space is going to be 12 different things. So for instance, a white bread sandwich, with ham that I can either do cheddar or Swiss. A sandwich with white bread that is turkey, cheddar, or Swiss. A sandwich with white bread that is either chicken, that is chicken, either cheddar or Swiss. So again, going back to the question at hand, in this particular case, I'm only able to get one sandwich that is that has Swiss and has turkey and is on wheat bread. Okay. Now, if it asks me what is the probability of getting a cheddar sandwich with wheat bread, in this particular case, I would have three different possibilities: wheat, ham, cheddar, wheat, turkey, cheddar, or wheat, chicken, cheddar. That's 3 of the 12, okay? Or 1/4 of those sandwiches would be that option. So the probability in that case would change. So let's go ahead and take a look at another example that we're going to create from scratch. So the example that we have in hand is about Matthias. Matthias gets dressed in the dark one morning and chooses his clothes at random. Okay, he chooses a shirt that would be either red, green, or yellow. Okay, and then he chooses a pair of pants that would be black or blue. Okay, and then he's going to choose a pair of shoes, either checkered or red. Okay, so what we're going to do is we're going to go ahead and we're going to create a tree diagram using all of this information. And I'm going to try to stick as much as I can to the color scheme with the colors that I choose. So the next screen that you see will be me actually constructing that. Okay, so if we switch over to our work, okay, again, this is part of 7.6i. 7.6i, again, is going to be all-encompassing with attempting to discover different nuances of probability. First thing I'm going to do is create, in green, we have a green shirt, okay? We then have a red shirt, okay? I'm trying to get my colors all together. We then have a red shirt. I then have a yellow. You know, some people don't quite see this as yellow. Some people see it more of as like a light green, but the consensus of people say yellow. I see a light green, but we're going to go with this as yellow. Okay, on the screen there it does look a little yellow now that I see it. All right, now for the pair of pants, we have two pairs of pants that they could possibly have. Okay, we have a pair of black, and I'm going to use the abbreviation BLA, I should say. I'm going to do BLA on this one, BLA on this one, and we have where we could do a blue pair of pants. Okay, and I'm going to do a blue marker here, and I'm going to say BLU, BLU, and BLU. Okay, so far. Now I'm going to use a pencil for the next one, okay, because that's going to require just a little bit more finery. So I'm going to say checkered. Then I've done my red. I am going to do checkered here, red here, checkered again, red, checkered again. So this is just a matter of me constructing everything that I need. Now, let's talk about, while I'm doing this, let's talk about a way that we could have checked our work or given ourselves a reasonable answer as to how many different samples or how many different options in our sample space there would have been. Okay, so how many options there would have been in our sample space. So I'm going to try to move this up if I can. So we know that if there were 3 options for my shirt, 2 options for my pair of pants, and then 2 options for my socks, we would have been able to multiply all of these across. Okay, so 3 times 2 is going to give me 6. 6 times 2 is going to give me 12 different possibilities in my sample space. So let's confirm. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 different options that I have in terms of how I could have randomly dressed in the dark, as the example said. So what I'm going to do at this moment is I'm going to switch back over to the problem so we figure out exactly what probability we are attempting to find. So we have 2 different probabilities that we can discover here. Okay, so question number 11 and question number 12. 11 says, what is the probability that Matthias will pick an outfit at random that includes red shoes? Okay. And then the probability for that no part of Matthias's outfit is red. So no part of his outfit is red. So the probability that there is no red, and I'm assuming that that would be no red shirt and no red socks either. Okay, so let's go back to our drawing. So number 11 said the probability of red shoes. So in this particular case, I am going to look at the last part here, this last column. That's going to be my sample space. I'm going to go ahead and identify this as my sample space. Okay, 12 possibilities in my sample space. Okay, so I'm going to have everything is going to be out of 12 because, again, look at my initial probability video for a little bit of intro into sample space. So out of 12 options, okay, the probability that he will have red shoes will be 1, 2, 3, 4, 5, 6. So if we think about that, about half of the time I'm going to have a red shoe because, again, I only have 2 different options for shoes. So half of those, 6 of 12 of my sample space is going to be red shoes, or 1/2, which equates to 0.5, or 50% of the time my outfit will include red shoes. So the next one says I don't want any part of my outfit to be red. Okay, so in this particular case, I can discount this part as well because I started with a red shirt. So I don't want any part of my outfit is going to be red. So I'm going to just go ahead and ice out that whole middle part. Okay. So in this particular case, I have yellow shirt, black or blue pants, the different kinds of shoes. Okay. So in this case, I don't want any part of my outfit to be red. So no part of the outfit is red up until the shoes. So 1, 2. Those two options. I can't pick any of these. 1, 2. So that's 4 total. So 4 out of my 12 options would satisfy that particular probability. In this case, 4 out of 12 is going to simplify to 1/3, which simplifies to 0.3 approximately, or 0.33 I should say approximately, and then about 33% of the time, randomly choosing those things. Okay? So this is theoretical probability presented through a visual called a tree diagram. Okay, if you have questions about this, you may go back through the video. If, in fact, you still have a question, please come to class with that question. I'll try my best to get it answered. And if that does not work, if you don't have, or if you forget to ask me in class, please come to a tutorial session so I can get that question answered for you. So, and as always, I will see you in class tomorrow.